Good morning, everybody. In previous lectures, we have seen how to separate oil, gas, water, sand. So, whenever we are getting oil, water, gas mixture with sand also, so we pass the fluid through separator systems. So, maybe vertical separator, horizontal separator, then there will be gas separation separately, gas treating system, amine treater, or there will be water removal systems. From oil also there will be water removal system, the sand removal system, water disposing system. Then after doing all those things, you got pure oil or crude oil. So that one you have to store before sending to your refineries. Even in refinery also, when they receive from oil field crude oil, they will have to store somewhere. Okay. Then they will be sending to this fractional distillation system. Fractional distillation system is actually you have to separating diesel, oil, kerosene, naphtha, all the things that you are getting, you are separating. So then how to store it? What are the design system required for your oil storage system? What are the criteria? We will try to discuss in this lecture. So production, refining and distribution system of petroleum products, or maybe I can say oil, crude oil, require storage tank. Okay. So small bolted welded tank possible. So this can be used in production field. Large welded tanks, distribution terminals and refineries can be used. Okay. Oil storage tanks are typically made up of carbon steel, stainless steel, industrial strength, plastic, reinforced concrete. Okay. So when I was talking about steel and carbon steel, I think you may have idea about material science. Pure iron is very much corrosive. Okay, you can create give small amount of carbon content in there, like 0.5% something, then you can create mild steel. So mild steel very easy to manufacture, it is very much ductile, malleable. If you manufacture using mild steel anything like your pipeline system, your surface production systems, anything, so it will be very much corrosive. So very much corrosive means that will be dangerous for your system. That will be giving like a contaminant of iron oxide, and it can be leakage, fracturing possible. So we should not use mild steel. So we will have to go towards stainless steel or carbon steel, that area. Carbon steel means carbon amount will be larger amount, and you want to reduce corrosion ability, so you add chromium. Okay, sometime so you are adding carbon, chromium, sometime nickel, molybdenum, some other components also you are adding to change iron property. If you are not changing, if you are keeping it pure form, it is very much corrosive. Okay. So that is not useful for your system. So Fe plus H2O plus iron plus water, it will create ferrous oxide and ferric oxide. So salt is very much softer. So you are not using mild steel actually. Okay. And even carbon steel and stainless steel, other steel also you are using, many time you use galvanization or surface coating you will be using, sometime you will be using painting also, so to protect the surface. Okay. For example, pumping system, you are not impeller you are using, in impeller you are not using any coating, but impeller material should be such designed such a way, or impeller material should be considered in such a way that there will be no corrosion, erosion will be minimized. Okay, so that it will be lasting longer and there will be no failure. So there will be some lifetime, like 2 years or 5 years or 3 years. So within that period it should not fail, or it will not get eroded or corroded. Your surface production system, tank, battery or tank systems also, you should consider material properly, otherwise there will be erosion, corrosion, and a system will not last longer, and that can give accidents also. Okay, if there is any fire source and lots of vapor going out in the atmosphere, then there will be big accident. So to avoid that one, what the parameters to consider, I will try to discuss. And many cases plastic tanks also used, reinforced concrete also used. And if you consider older days, people were used to use the wood, okay, wood based tanker system. So later they thought like wood is very lower level thing, it cannot withstand very much high pressure, and fire also will be on problem. So they moved to metal side, and metal side also metal is very much heavier, so they moved towards reinforced concrete, FRP. Okay, plastic made system also there, but again plastic, when you are using, temperature also one problem. Okay, if temperature is going very high, then your ductility will change, or leakage can be possible, or a small fire or high temperature is there, it will be melting quickly, right. So there are positive negative aspect in both sides, like metallic or non-metallic you want to use. Wooden people are not using these days. Okay, people are using metal or plastic or reinforced plastics. Okay, so plastic will be having some metal whiskers and they will be making stronger. So plastic property they will take and metal strength also they will take. So together they will make reinforced plastic. Okay. Sometimes this FRP, fiber reinforced plastic. So lots of fiber, metal fiber will be there, and outside like tire, if you cut any tire, there will be lots of wears, small wears, cotton will also be there, right. So they will make stronger. But if you see rubber, tire actually made up of rubber. Rubber is not having good strength, like tensile strength, it will break quickly. So they will be putting like cloth or maybe metal wear. So it will make stronger. So similar way, the reinforced plastic will be making like metal wears and other things will be there. So that will be giving you high strength, tensile force actually, and you will get property of plastic also. So that way they are making the tanks. And basically I did not take from any single document, I have taken from many documents to prepare this lecture. So petroleum engineering handbook chapter 3 also, oil storage system, some information will be there. A similar system, similar information is also there, PetroWiki website also there. Some and figures I have taken from different sources. I have given source also, you can click there and you can read more information. Okay. So type of storage tank different size and shape possible, 500 barrel to 5 million barrel also possible. Okay. Special application, rectangular, horizontal cylinder possible. Horizontal spherical full pressure storage, hydrocarbon or chemical products will be there. So if a very large storage tank will be used for like refinery side, but for your production side it will be smaller size normally. Okay. Atmospheric low pressure tank widely used. Common low pressure tank means like atmospheric pressure. So you are not giving extra pressure in the tank. Okay, you put fluid and you are not giving extra pressure. So that is atmospheric tank. Okay, so inside tank pressure, here inside pressure and outside atmospheric pressure will be almost equal. Okay, common shape can be vertical, cylindrical, circular shaped. Vertical shape will be there. Gross capacity 100 to 1.5 million barrel. Okay, so you see this so big, million barrels, not 150 or 15,000. Okay. Corresponding tank size ranges from diameter will be 10 feet minimum to 412 feet. Okay. So it's so huge. So more than 100 meter, right? 412 feet means around 150, 100 to 150 meter diameter. So this is diameter. Okay. So small 10 feet to 412 feet, that much of diameter possible. Okay. And whenever considering tank, so you have to understand different fittings, equipments. Okay. So one thing here left side I have drawn this one. This is called cat and mouse type level indicator. Like inside tank, how much fluid is there? Is completely metal. You cannot see from outside. Okay, accessing is not so easy. Okay, so you put like say liquid level is here. Okay, you have one small float. Okay, so liquid level is moving up. This float will be moving up, and there will be some pulley system here. Okay, so pulley will have one mass. Okay, when liquid level is moving up, the mass will be going down. Okay, so this is called a cat and mouse type level indicator. Okay, and there will be scale around here. Okay, so you put scale 0, 1, 2, 3, 4, 5. Okay, accordingly you can so scaling also you see from opposite way you have to give, from not from bottom 1 to 3, from top you have to start, then you can see how much fluid is there, right. It will be easier to read. Okay, so there will be level indicator, there will be hatch. Hatch means accessing there inside tank, what is there, how much fluid is there, fluid property measuring, those things should be accessed from certain point. Okay, and this is completely metal or maybe plastic or reinforced plastic. Okay, there will be venting system. Venting system will be required because if there is vapor, okay, so vapor will be getting accumulated, so vapor should be vented out properly. If you are not venting properly, then pressure difference, it will be sucking atmospheric air. So when air is sucked and vapor is there, so vapor and air, it will be creating combustible mixture. If there is any fire source from anywhere, the whole thing will get busted. Okay, so vented system, there may be flame arrestor. Okay, so when vapor is going out and if there is any fire source, so outside flame will be there, but the flame should not enter into the system. Okay, if flame is entering, then done. Okay. Then there will be inlet port, outlet port, many ports will be there, pressure sensor will be there, temperature sensor will be there. So, all the system will be fitted in your tank system. Okay, these things, these pictures I have taken from saferack.com and instrumentationtool.com, these two. Okay. Now, there will be different types of tanks. Fixed roof tank is like simple cylinder and roof is fixed, roof is not moving or anything. Okay. So, this is called fixed roof tank. So, dynamic roof, another type of tank will be there. Dynamic tank roof will be like this. One roof will be there and liquid is here. Okay. So, you inject more liquid, roof will be moving up. Okay. So, roof will be moving up, again roof will be moving down. If you are removing liquid or oil from there, so roof will be going down. So, there will be floating roof. Okay. Okay. And in fixed roof, roof is not moving, roof is not moving. Okay. So, dynamic roof rises and falls depending on the oil level. Okay. So, this floating roof or dynamic, here the term is used, I will write floating also. Okay. So, floating roof is moving up and down. So, roof will be designed such a way that will be move up and down. Okay. The purpose I will explain later. So, it will be minimize vapor accumulation, reducing evaporation loss. Evaporation loss is when a fluid is there inside tank. So, fluid particle will be leaving surface and it will be accumulated in the vacant space. Okay. Like say I have one fixed type roof and liquid is here. So, this area lots of vapor will be there. Okay. Now, if I have fixed roof, floating type roof. Okay. So, this upper surface of the liquid I am not giving it free. Okay. So, the vapor will not be leaving the surface, but in this case vapor is leaving the surface, and how much it will be, how much vapor will be leaving. So, it will be creating one equilibrium. What will happen? Let us say one vapor particle leaving, so many vapor particle will be leaving, it will be filling the space, and some vapor particle, because of a Brownian motion, some vapor particle will be falling down on the liquid surface also. So, that process will be continuing. This is called a dynamic equilibrium condition. Okay. So, in that vapor space will have certain amount of vapor, that fixed amount of. Okay. But if you have that floating roof, the floating roof means it is not allowing vapor particle to move up. Okay. So, the vapor particle they will not get any Brownian motion. Okay. Brownian motion means it will be living, then it will be moving randomly, right. But when you have fixed floating roof touching the surface, particle not leaving, so there is no Brownian motion. So, vapor loss will be lower, okay, in floating case. So, common in production facility, okay, use vapor pressure less than 1.5 psi. It is common in production facility. Vapor loss can be high during tank filling operation. Okay. When tank is getting filled, let us say initially tank is half filled, some portion fixed roof tank is there, some portion is filled with vapor. Okay. Now, you are filling the tank, so that vapor must be going out because you are filling liquid, right. So, 50% let us say filled with vapor, 50% liquid, you are increasing liquid level, so that must be going out, then liquid can be filled. Okay. So, internal floating roof reduces the vapor loss. Internal floating roof is there, so that I do not have that much free space. So, just you fill it, so there is no loss. Okay. Fixed roof tank, low hydrocarbon vapor pressure or vapor pressure close to atmospheric pressure. Okay. So, for that you are using fixed roof tank. Okay. Like a very high volatile liquid you are putting in tank, then in fixed roof tank actually you will have lots of vapor. So, losses will be higher. Okay. So, in that case you can use floating roof tanking system. Okay. Another system is the bundled oil tank. So, tank within a tank. So, just for safety purpose. So, one tank is there, outside there will be another tank. So, if any spill leakage is there, so tank or system can be safe. Okay. Preventing oil from seeping into the surrounding. Okay. This is called bundled oil tank. So, fixed roof tank, they will have one gauge hatch. Gauge hatch means, if you see the definition, gauge hatches are designed to provide accessible entry for inspection, measurement and sampling inside. So, tank is here. Okay. So, tank, there will be this system will be fitted somewhere. Okay. So, that handle is there, just remove it, then you put your probe to measure, you see the liquid level, how much water is there, water and because water will be also getting deposited at the bottom. So, that level you can check, you can measure, you can create, you can check sample quality of oil. Okay. So, that you can access from this one, because whole tank will be completely closed. Okay. So, you will have some specific, because 412 meter, that fit that much of diameter, you cannot access randomly here and there. Okay. There will be some ladder system outside, from ladder you enter and you access through hatch and you check your fluid thing. Okay. So, gauge the tank, determine water presence if water is there, measure the height of the oil water interface, take sample of crude oil. Okay. So, basically these things will be done using your gauge hatch. Okay. So, filling and pumping operation, oil removed from the tank, air drawn into the vapor space, create a hazard. Okay. When you are filling oil, that vapor space, the vapor will be getting removed, right. So, that will be creating, going outside. So, that can create hazard if there is any fire source anywhere. So, that can be dangerous. Even you can remember few years back, there was instruction in petrol pump area, you should not switch on your mobile. Okay. And now I think things are better, because mobile, when if any ringing is there, that will create some small spark, that spark created some fire actually in petrol pump area, because petrol pump area means when it is filling, you are filling your car or bike. So, some vapor will be in the atmosphere nearby. Okay. So, just to prevent, the government instructed not to use mobile phone inside petrol pump area. Okay. I think that instruction has removed most probably. Tank filling, okay, tank filling, evaporative breathing increases. Breathing means like when tank is there, so during daytime temperature will be very high because of direct sunlight falling on this. Again night time maybe temperature will be going down. So, temperature going up and down, and that vapor space, vapor will be expanding and contracting, again fluid temperature increasing, that will be leaving more vapor. That means some inside vapor space the pressure will change actually. When pressure is changing, so some vapor will be going out, again temperature going down, air will be sucked. Okay. When air is sucking, that you have to control actually, if because air and vapor mixture will be creating combustible mixture. Okay. So, that will be dangerous. So, during tank filling, evaporative breathing increases, oil added to the tank displaces air vapor mixture through the tank vent, resulting in significant evaporative emission. Okay. And yeah, so you have to check hazard part and how much losses are there because of evaporation, because during filling some vapor will be going out, during temperature change day and time or pressure change, the some vapor will be going out. So, that also you have to consider when you are considering any tank system. Okay. So, fixed roof tank. So, sometimes they use gas blanket system. So, gas blanket system is artificially they will be increasing some pressure inside tank. Okay. So, that there will be no extra air. Air means oxygen mixed nitrogen, oxygen plus nitrogen plus all the mixture should not enter into the system. So, inside pressure you keep a little bit higher. So, outside fluid air will not enter in the system. Okay. So, oil vapor pressure is very low, use freely ventilated fixed roof tank if incoming oil vapor exceeds atmospheric pressure at ambient temperature. Okay. A gas blanket system maintains positive tank pressure and minimize the chance of air being drawn into the tank vapor space. Okay. Air means actually basically this is the dangerous thing. Okay. Nitrogen is mixing, nitrogen inert gas. So, it will not be creating any trouble, but oxygen is trouble. Okay. So, during no inflow period, tank breathes, air enters the tank through the pressure vacuum valve, forms explosive mixture. Okay. So, gas blending system, a supply of natural gas at a pressure regulator keeps tank pressure at predetermined level. So, tank pressure you are keeping at higher level, so that incoming inbreathing will not happen. Okay. Regulator closes as P increases by sunlight, P vent opens if P continues to rise to atmospheric or some downstream vapor recovery process. A vacuum relief used to protect the tank against vacuum should the gas blanketing system fail. Okay, if gas blanket system is failing, then you have to have some alternative option. Okay, because gas blanketing system means you are giving extra pressure. Because of failure, if you are getting extra air sucked, so you must have an alternative arrangement for safety purpose. Okay, so you are giving all these things for safety reason. Okay, so sometimes losses can be allowed, but safety cannot be compromised. Okay, because safety compromise, there will be the severe consequences. Let's say political and social issues may be arising, so that will be harming whole ecosystem of your business. For example, you have one oil tanker and suddenly got burst, 5 people died or 1 people died. Now that will be creating a political issue. So that political issue, we don't know where it will be reaching, right? For example, several accidents happen, chemical and other accidents in India also, and you have seen the cases still going on. Okay, the company got bad reputation, cases still, many people suffering, still suffering, right? So, so that's why safety should not be compromised at any level of your oil and gas industry. Okay, safety must be first priority. Okay, it is not the last priority or least priority. It must be the first priority. Yeah, about safety, when I was working in the oil industry in UK, so that time they sent me for one safety passport training. So how to work in the laboratory, all these things, 4 days training was there. They gave me a certificate also. And whenever we will be working in the laboratory, we will have to wear this hard hat, goggle, shoes, and a high vis dress, and gloves also must be there, because that was the laboratory instruction. If someone is not following, immediately the person can be expelled from the laboratory. Okay, and UK's HSE, Health and Safety Executives, they will be entering laboratory anytime. No one can prevent them, and if someone is preventing, that means something is wrong. Okay, so they can access anytime, they can check system safe or not, and people cannot blame, like say my boss told, that's why I am doing this one, or boss cannot say the lower level engineer has done, I did not know that. Okay, if you are involved, you are responsible. Okay, you cannot pass blame to others. Okay, that sort of strict rules regulation is there. So normally that will be the standard rule for all oil and gas industry operations all over the world. Okay, because safety is the first priority part. Okay, so whenever you are designing, handling things also, safety must be the first priority. Okay, not the least or not the second priority. Okay, so sometime this will be linked to your life also. For example, offshore operation you are doing, and if something is unsafe, so it will be linked with your life also. Okay, so fire exposure out. Okay, so outbreathing is when pressure is high, internal pressure, so vapor will be going out of the system resulting from the fire exposure may exceed design or venting rate based on normal operating condition. In such cases, the construction details of the tank determine whether additional venting is required. Okay, so venting is proper way you are disposing, but a venting system will have like fire catching system and other system. So through that you can vent. Okay, because you know how much vapor is going and how to handle it, but if it is exceeding your that calculation limit, then you have to set maybe another venting system. Okay, that they are saying additional venting may be required. On fixed roof tank, their roof shell joint considered frangible. Okay, roof and shell. Okay, so those joints may be a little bit frangible. Okay. Excessive internal pressure gives it failure. Additional requirement for emergency venting may be required. So again, safety. Okay, for everything is about safety.